All right, so we're looking at trig functions. So what we have here, we have sine, cosine, and tangent. So we're going to start with angle A down here. So this is angle A. And we have the sine of A, which is the lowercase a over c. So we're going to use this to explore how we've labeled things. Capital letters A, B, and C represent angles. Lowercase letters A, B, and C represent sides. Furthermore, C is a right angle. So that is one of our requirements here. C must be a right angle for this triangle. Therefore, lowercase c is the hypotenuse. Lowercase c is the hypotenuse, while A and B are the legs. So with the sine, we said the sine of A is the opposite over the hypotenuse. The cosine of A is the adjacent over the hypotenuse. And the tangent of A is the opposite over the adjacent. So you can add these generalizations. So sine of some angle. So in order to avoid confusion, we'll say alpha, which we don't have in our diagram. Sine of an angle alpha is the opposite over the hypotenuse. The cosine of an angle alpha is the adjacent side over the hypotenuse. And the tangent of an angle alpha is the opposite over the adjacent. So here we have our various options. So if we're looking at angle A, we've got a couple of ways, or a couple of statements we can write. We have a sine, a cosine, and a tangent, as shown here. So the opposite is lowercase a over the hypotenuse, c. For cosine A, we have the adjacent side, b, over c. And for tangent, we have lowercase a over lowercase b. The same thing can be done from angle B, but now, when we're looking at angle B, the opposite is lowercase b, hypotenuse is still c. Looking at cosine, the adjacent is a, the hypotenuse is c, and when we're looking at tangent, we have opposite over adjacent. So that's our three trig functions, our basic trig functions. So let's take a look at a triangle with some numbers in there as an example. So if I create a triangle here that was 3 units here, 4 units here. So we have A, I'll say this is 5 units here, B, and C. So even without knowing the angles themselves, I know that the sine of angle A must be the opposite over the hypotenuse, so 3 over 5. The cosine of angle A must be the adjacent over the hypotenuse, so 4 over 5. And the tangent of angle A must be the opposite over the adjacent, so 3 over 4. We can do the same thing for B. So sine B will be the opposite, but now the opposite of B over here is 4. So we have 4 over 3, or I'm sorry, over 5. The hypotenuse stays the same. The cosine of B, which is going to be the adjacent, 3 over the hypotenuse, 5. And the tangent of B, which will be the opposite, 4 over the adjacent, 3. All right, so here we have an application problem. A tree casts a shadow that's 15 feet long. The elevation, or the angle of elevation of the sun is 30 degrees. How tall is the tree? So here we have a picture of the tree and its shadow. The shadow is 15 feet. So we want to know the height of the tree here. We connect these, and of course this is not to scale, but they told us that this would be a 30-degree angle. So if we have an angle, and we have here the adjacent side, and we want to find the opposite side, we're going to be dealing with tangent, because remember the tangent is the opposite over the adjacent. So we take the tangent of 30 degrees, that must be equal to h, the opposite, over 15, the adjacent. Multiply both sides by 15. So 15 tangent 30 degrees is equal to the height. And we can put that into our calculator and round it to the nearest whole value. Make sure that your calculator is in degrees before doing so. If it's in radians, you will need to switch it. And we get that that is approximately 8.7 feet tall. And that's it.